Okay, so now equipped with the law of cosines and the norm of a vector, which gives us its length, we are now ready to tackle the problem of finding the angle between two vectors. So recall, if I have two vectors u and v, I can now generate or create a triangle by first positioning the vectors v and u so that they start at the same place, and then I will join their terminal points in order to create the vector v minus u, which is the difference between them. So maybe let's redraw this triangle here, and using the norm, I have the length of all sides of this triangle, because if I'm given the coordinates of v and u, I can calculate the norm of u and the norm of v using the formula. I can calculate v minus u, which will give me another vector, and get its norm as well. So maybe just to show an example, let's say I have u, which is the vector with coordinates, I don't know, maybe it's 4, 2, and v is a vector with coordinates, maybe it's 7, 1. Okay. Then I can create or calculate the vector v minus u, so that will be a vector with coordinates 3, 1, right? 7 minus 4, 3. 1 minus 2 minus 1, so there's a little minus here. And then I can calculate the norm of each of the vectors in order to get the length of each of the sides of the triangle. So here, if I calculate norm of v, that's the square root of 7 squared plus 1 squared, so it's square root of 50. So that would be square root of 50 here. U, its norm would be 4 squared plus 2 squared, so that's square root of 20. And v minus u, well, I'd have to calculate it, right? So, well, we said it's 3 minus 1, so its norm would be 3 squared plus minus 1 squared, so that's 9 plus 1, so that's square root of 10. Okay? And then, in order to calculate theta, I could apply just the law of cosines. Okay, so I'll just, so my goal is to get a formula for theta, actually for cos of theta, in terms of the coordinates of u and v. So let's go back to this diagram here. I will apply the law of cosines. Okay, so the side that is opposite to theta is this side. So the law of cosine says that this side, this side squared will be equal to the sum of the square of the other two sides minus 2 times the product of the other two sides times the cosine of theta. So that's the law of cosines. Okay. Now v minus u, we said we get it by subtracting the coordinates of u and v. So if u has coordinates u1, u2, v has coordinates v1, v2, well, v minus 2 has coordinates v1 minus u1, v2 minus u2. So let's use this to calculate the norm. So the norm is going to be, well, the norm is the square root, but now the norm is squared, so let's, that removes the square root, so it will be the sum of the other of the two coordinates of v minus u squared. u1 squared plus u2 squared, so that's the norm of u squared. That's the norm of v squared, and we'll see that for some reason I'll just keep norm of u and norm of v as they are here for now. Okay, but I could write this as square root of u1 squared plus u2 squared, but you'll see that It will make things easier to work with if I just keep it the way it is right now. Now I'm going to expand these two expressions here. Okay, so what is that? That's v1 squared minus 2u1 v1 plus u1 squared, right? That's just applying the formula that you know from high school, from Cal 1, a minus b squared, that's a squared minus 2ab plus b squared. I'm going to do the same thing here. Here we go. And on the other side, I'll just keep things the way they are. So I'm not changing anything here. Here we go. And notice something. I've got on this side this, which matches this, and this. So I can just remove everything on each side. And what am I left with? Well, I'm left with a minus 2. That actually shows up in both of the other two terms, so I can factor it out. So I've got minus 2 times u1 v1 plus u2 v2. That's equal to minus 2. Notice the minus 2 again on the other side. Norm of u, norm of v, cos theta. So of course now I can divide by minus 2 now on each side. And I get this very precious, very precious identity, which is that if I do u1 v1 plus u2 v2, that's going to give me norm of u, norm of v, cos theta. We're going to frame this. That's kind of important. If I want to get the value of theta, all I need to do is solve for theta. So cos of theta is u1 v1 plus u2 v2 over the product of the norm. Okay. So to give you an idea how this works, let's just go back to the example we had up there with u is 4.2, v is 7.1. Okay, I'm just going to recopy that example. U is 4.2 and v is 7.1. If I want to calculate the angle between the two vectors, I would first calculate the cosine of the angle. So all I need to do now is multiply the coordinate of u with the first coordinate of u with the first coordinate of v. And sorry, that's 4. So that would be 4 times 7 plus 2 times 1. And I would divide by the norm of u, which is square root of 20, times the norm of v, square root of 50. So that would give me what? 4 times 7, 28 plus 1. So that's 30 over, well, essentially the square root of 1,000. So using my calculator, if I evaluate this, this is, well, approximately 0.9487. And if I want theta, I will take the arc cos of this value using, again, my calculator. So again, that's approximately. And I will get, what's the arc cos of this? It's, now you have to be careful whether your calculator is set in radians or degrees. That will change the answer. Mine is right now set in degrees, so I get 18.43 degrees. And that's the angle. See, it's that easy now. Just from the coordinates of u and v, we can easily calculate the cosine. So notice I didn't have to draw a triangle and apply the law of cosine. All this is now given through this nice formula that we have here. I didn't frame it, but I should have. Okay. Now, the top part of the formula is so important that we call this expression that you see there the dot product. Okay. Um, and okay, so everything I've done here is with vectors in 2 space, but I could have done the exact same thing with vector in n space, and I would have obtained the exact same not the exact form, not the same formula, because here I've got u1 v1 plus u2 v2. But if I would be in Rn, so in general, so in Rn, the cosine of theta, it turns out to be u1 v1 plus u2 v2 plus un vn, and divided by the norm of the vectors. And the top part, like I said, is called the dot product. So we'll define this here. So definition, the dot product, and the way it's written down, we write it as u dot v. Like, make sure this is like a big bullet. U dot v is defined as the component-wise product of the coordinates of u and v added up, like that. So using this notation, we can rewrite the two identities that I framed up there. We've got that the dot product u dot v. Well, first of all, it's u1. It's u1 v1, u2 v2 plus un vn. But what I wanted to write is not this. I want to write what you have there: norm of u, norm of v, cos theta. So that's the first identity. Okay. And if I solve for theta, the cos of theta will be the dot product divided by the norm of the vectors multiplied together. And that's, so we use the second one whenever we want to calculate the angle between two vectors. And of course, the expression on the right will take the arc cosine of that to get the angle. So I'll show you another example. I'm going to find the angle between these two vectors that are in R3. Notice if I want to do this with geometry in R3, that's difficult, right? Because just picturing those vectors in R3, that's going to be hard. But I don't have to do this. I've got a nice formula to work with that doesn't involve geometry. That's the cool part about these formulas. I don't have to rely on geometry. And in fact, they work in Rn. And in Rn, I can't do any, at least I can't draw anything in beyond R3. So all I need to do now is calculate the cosine of theta. So I apply the formula u dot v divided by norm of u, norm of v. Now what's u dot v? It's minus 1 times 1 plus 2 times 1 plus 1 times 1. Right? So I multiply the components together and I add them up. And I'm going to divide by norm of u. So that's going to be square root of 1 plus 4 plus 1. Norm of v, 1 plus 1 plus 1. Well, they're all squared, right? But 1 squared is 1. So at the top, I'll have minus 1 plus 2. So that's 1 plus 1. That's just 2. And here, this is square root of 6, square root of 3. So I have 2 over square root 18. I will take the arc cos of this. So theta is arc cosine of 2 over root of 18. If your calculator is set in radians, it will be 1.08 radians. And that's approximately 61.9 degrees. So I have, from this, I know that the angle is acute, right? But is it possible to know whether the angle's acute without calculating the angle? Yes, it is. All we have to notice is that, remark, the angle is acute when cos of theta is positive, right? If you have, remember, right? If you have the trig circle, those are acute angles and those are obtuse angle. And over here in this quadrant, cos of theta is positive. In this quadrant, cos of theta is negative because the cosine is the x coordinate of the point. Okay, so it's going to be positive when the cos of theta is positive. If I go back to my formula for cos of theta, the bottom part is always positive because it's the product of lengths of vectors, and those lengths are positive by definition. Right? The norm is a square root of something, so that's going to give us positive values. So the sign of cosine only depends on the sign of the numerator. So the numerator is just the dot product. So if the dot product is positive, you have an acute angle. You have an obtuse angle when cos of theta is negative. And that's going to occur when the dot product is negative. And you have a right angle when cos of theta is equal to 0, because when you're up there, you have got an x coordinate of 0 and you've got a right angle. So that's going to occur when the dot product is equal to 0. That's really important to remember, especially the last line. When you've got a right angle, you have a dot product that's 0. So looking back at our calculation up there, the dot product was 2. So that's the only thing I needed to look at in order to decide whether it's acute or not. I've got a positive cosine. I've got a positive dot product, so I've got an acute angle. If I had a 0 in the numerator, I have a right angle between the vectors. And if I have a negative number in the numerator, I have an obtuse angle. So there's no need to calculate this part if you're just asked to decide if you have an acute, an obtuse, or a right angle.